Today we'll be graphing linear inequalities when they're given in standard form. So we're going to go over some skills we've actually already learned. When we are given an inequality in standard form, we are going to graph it by first converting it to slope-intercept form. So standard form is ax plus by equals c. So in standard form, x and y are on the same side of the equal sign. And we want to convert it to slope-intercept form, which is y equals mx plus b. And the other skill that we have already learned before is how to solve inequalities. So we will just be combining those two skills we've learned, converting from standard form to slope-intercept form, and the rules for solving an inequality. Linear inequalities written in standard form can be converted to slope-intercept form by solving for y. And you do that by performing inverse operations. We've talked about inverse operations when solving equations. Those are the operations that undo each other. So adding and subtracting are inverse, multiplying and dividing are inverse. So you need to make sure that you remember the golden rule of inequalities. This is the most important thing, mainly because it's forgotten. And if you forget it, you'll end up with the wrong answer. The golden rule is that if you multiply or divide by a negative number, you must flip the sign. So this goes back to an objective we did in Unit 1, solving inequalities. If you multiply or divide by a negative number, you must flip the inequality sign. Let's go over some examples. Write each equation in slope-intercept form, identify the slope and the y-intercept, and then we're going to graph it. So here we're given 3x plus 2y is less than or equal to negative 10. That's given in standard form. We need to convert it so that y is by itself on one side. So first, the inverse operation would be to subtract 3x. Now we have 2y is less than or equal to negative 3x minus 10. And then divide each term by 2. So now we have y is less than or equal to negative 3 over 2x minus 5. So let's identify m and b and then graph this. So my slope is negative 3 over 2. That's my rise over run. And b is negative 5. That's my y-intercept. So I'll plot negative 5 on the y-axis. And I need to go down 3 and over 2. But since I can't, I'm going to reverse that and go up 3 and 2 to the left. So let's say I could go down and this graph was bigger. I could, and I would probably end up somewhere around here. But since I ran out of graph, I'm going to reverse that. So up 3 and 2 to the left. And you can see that that is falling in line with where it would be if I was able to go down farther. So up 3 over 2, and I'm just going to do that until I run out of graph. Going back to my original inequality here, y is less than or equal to, that means that I will be using a solid line. Less than or equal to means that I can use a solid line, not a dotted line. and I'm going to be shading below the line because it's a less than. Okay, number 2. 15x minus 3y is less than negative 9. So first step is subtract 15x. Negative 3y is less than negative 15x minus 9. Divide by negative 3. Now, I just divided by a negative number. This is where you can't forget. If you're dividing by a negative number, this symbol has to flip around. So now it's going to point the other direction. So I will end up with y is greater than positive 5x plus 3. My slope is 5 over 1, and my y-intercept is 3. So I will plot positive 3, and if I wanted to go up, I would probably end up somewhere up here, probably where that m is. But since I can't, I'm going to reverse it and go down 5 and 1 to the left. Now the symbol does not have the line under it. It's not a or equal to. It's just y is greater than. So this will be a dotted line. And since y is greater than, I am shading above the line, which is to the left in this case. Number 3, 4x plus y is greater than 0. Subtract 4x. Y is greater than negative 4x, and I don't need the plus 0. Y is by itself, so I'm done. I've converted it. So m is negative 4 over 1, and b is 0. So b is going to go right here at the origin, down 4, 1 to the right. And I'll go back the other direction as well. This one will be a dotted line. And I'm shading above the line, which in this case is to the right. Y is greater than negative 4x. Number 4, y is greater than or equal to negative 1. So here we have an inequality where there is no x. So you need to remember the acronyms we learned for horizontal and vertical lines. Remember HOI and VUX. So if I have a y is greater than negative 1, that's going to be this one, which is going to be a horizontal line crossing the y-axis at negative 1. So negative 1, and this is going to be a solid line because it is a or equal to. And y is greater than, so I'm shading above the line. A vertical line would start with x, and there would be no y in the equation. 2x minus y is less than or equal to 4. Subtract 2x. So now I have negative y is less than or equal to negative 2x plus 4. Remember, this is a negative 1, so I'm going to divide by negative 1 and make sure you remember when you divide by a negative number, we have to change this sign. So now this becomes greater than or equal to. So y is greater than or equal to positive 2x minus 4. M is going to be 2 over 1, and b is negative 4. So plot the y-intercept, and now I go up 2 and 1 to the right. And because this is greater than or equal to, it will be a solid line. And we will be shading above the line. All right, last example, 4x minus 3y is less than negative 9. Subtract 4x, negative 3y is less than negative 4x minus 9. Divide by negative 3. And when you divide by a negative number, that means this symbol has to flip around. So this will become greater than. Y is greater than 4 over 3 x plus 3. M is 4 over 3, and b is 3. Plot the y-intercept, and I would go up 4 and over 3, but I'll end up off the graph. So reverse that and go down down 4 and 3 to the left. Y is greater than, so this will be a dotted line. And we will be shading above the line because it's greater than. So that is how you graph an inequality when it's given to you in standard form.